This is Unit 1C, the test review. We're looking at an equation of a circle. To write it in standard form, that would mean to say x minus h squared plus y minus k squared equals the radius squared. That's the format of the standard form of a circle. So what we're going to do is take our problem here and bring our like terms together. We're going to bring our x's together, we'll leave some space and bring our y's together. Then I'll move the constant number over to the other side. Then we'll complete our square of both the x's and the y's. So I have 36. So I'm going to add 36 to this side, and I'm going to add 36 to the opposite side of the equal sign to keep it balanced. So here we would take our 2, divide it by 2, 1 and square it. So I'm going to add 1 to both sides. So I'll need to do that also to the other side. When we completed the square, that gave us x minus 6 squared. It's this value here that is going to be put inside our parentheses. This is a perfect square trinomial written as x minus 6 squared. This one here is y plus 1 squared. It's the item that's being squared is the number that goes inside your parentheses. And in this case we have 36 plus 1 is 37, and 15 sounds like 22. So if we're going to find the center is 6 comma negative 1, and our radius is going to be the square root of 22. So we'll try it again here. You can pause the video and you can try it yourself. I'm going to move my x squared over to the other side, move my 4x over to the other side because I want my x squared to be positive. I don't want it to be negative. I'm going to move my y over to the other side. I'm going to move my 12y over to the other side. I'm going to leave my 129 over here on the left hand side of the equal sign. So now we complete the square. We take the 4, we divide it by 2 and square it. So we are going to add 4 to both sides of our equal sign. And then we're going to take the negative 12 divided by 2 and square it. Got to use parentheses around that. So you have 36. And you add that to the other side. This becomes 40. So 169 equals x plus 2 squared and y minus 6 squared. So our center is at negative 2 comma 6, and our radius is 13. It's the square root of 169. To simplify a radical, we just need to be breaking it down into the parts that make it, that are factors. So I know that a 2 goes into there, and that's 121, and that's a number I recognize. That's 11 squared. So if that's a perfect square, I can pull that out, leave the 2 inside, and I've simplified it. Here we've got the 10 and the 14. We could multiply those together and get 140, but there's really no need to make the numbers bigger. I just need to break down what I have. So I look for my factors of 10, I look for my factors of 14, I have a pair of the same numbers. So that's going to bring my 2 out, and I leave my 35 inside the radical. Here we need to multiply by the conjugate. And we distribute that through to get 12 minus 3 root 5. And then when you multiply the conjugate, your middle terms are going to cross out, and you're only left with the first and the last. So negative 5, because root 5 times root 5 is 5. So that's going to leave us with 12 minus 3 root 5 over 11. Again, we have a binomial in the denominator. It has a radical, so we have to multiply by what's called the conjugate. The conjugate is the opposite sign of that binomial. I would distribute through to get negative 30 minus 6 root 11. And when you're multiplying conjugates, you only have to worry about the front term and the last term. Root 11 times root 11 is 11. So here we have negative 30 minus 6 root 11 over 14. And I notice that they all have the same factor in them. They all have a factor of 2. So this can be reduced So for number 7, 48 months, the average monthly operating cost for a small business can be modeled by this equation, where T is a number of months, during which month was the average operating costs so much. So when is our operating cost that much? So we'll take 1430 and we're going to subtract 550, we get 880. Then we divide by 0.55. When you divide by a number that is less than 1, you're going to make the answer bigger. Then we take the square root of both sides. So to answer the question, during which month was the average operating costs 1,430? That would be the 40th month. If you wanted to get crafty, you might say that 40 divided by 12 is going to be, it's 3 full years in there. And then 33% around, so that would be 4 in 4 months. So 3 years and 4 months. The height of a triangle is 4 inches less than the length of the base. So whatever the base is, the height is supposed to be 4 less than that. If they're perpendicular, then you know that you're dealing with height and base. The area of a triangle is half base times height. We know that the area is 30. So we can distribute that through to get x squared minus 4x. And then we could either take halves or I can multiply by 2. So I'll choose to multiply by 2. Then I need to bring everything over to the same side of the equal sign. If it's factorable, you can use factoring. If you don't recognize what it is, you could use completing the square. So it doesn't look like this is factorable. One way we can test it is to do b squared minus 4ac. B squared minus 4ac. So this is 16 plus 240. Oh, look at that. That's 256. That is most definitely factorable. All right, let's go factor it. So what multiplies to be negative 60? Well, there's a whole list of options that make negative 60. We know that the larger number is going to be negative. So 1 and negative 60. 2 and negative 30. 3 and negative 20. 4 and negative 15. 5 and negative 12. 6 and negative 10. There it is. 6 and negative 10. So positive 6, negative 10. So then you do the zero product property. So x is going to be 10 because x is not going to be negative 6. So find the height. The height is going to be 10 equals x minus 4. Nope, not exactly. 10 is your x. So 10 minus 4 is 6. So your height is 6. Be sure you answer the question. Okay, the dimensions of a rectangular garden are 10 by 25. You want to quadruple its area by adding the same distance to both. So we have a rectangular garden. We are 10 by 25. So the current area is 250. We're going to add the same area, or the same length, to both the length and the width. And now we want to be 4 times that amount. We want to be 1,000 for an area. Find the area of our garden. So 4 times 250 has to equal x plus 10 and x plus 25. You could call that 1,000. Find the area of the current garden. I didn't answer the question. The current garden is 10 times 25, so that is 250. These are feet squared. Write an equation to find x. So that is quadruple, means 4 times. And we know that we're going to have some amount plus the 10 and some amount plus the 25. That is our equation. Find the value of x that helps us. So we have 1,000 equals x plus 10, x plus 25. This becomes x squared plus 35x plus 250 equals 1,000. We're going to subtract that over. We get negative 750. So maybe this is factorable. What I'm going to suggest is we could just use quadratic formula. If it doesn't jump out at you, don't waste your time looking for it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 35 plus or minus 35 squared minus 4 times a times c. We get 4,225. And when we try to take the square root of that answer, we get 65. So x equals negative 35 plus or minus 65 over 2. So the only answer that's going to give us a positive number is negative 35 plus 65 over 2. So that comes out to be 15. So x is 15, and we could test that out. We could say 10 plus the 15 and 25 plus the 15, and when we do that base times the height, we should get an answer of 1,000. Perfect. Find the length and the width. The length, they called it, if it's length and width up here, if length is a 10, so it's 15 plus 10, so that's 25, and the width is going to be 15 plus 25 to equal 40, and 40 times 25 is our 1,000. And that's what we were trying to get it to be. On the flip side, if a rock is dropped, we're going to use this formula. So h of t equals negative 16t squared. Stands for the gravity. The initial height is 30. So we want to know how long will it take it to hit the ground, or hit the water in this case, so that's 0 for a height. So we subtract the 30 over, divide by 16. So t squared is going to equal, and we'll reduce that. So it's 15 over 8. We could either do 15 divided by 8 as a decimal, or we could just work on taking the square root of both sides, so we get plus or minus the square root of 15 over 8, which is plus or minus the square root of 15 over the square root of 8. That is the square root of 15 over the square root of 2 root 2. We have to rationalize that denominator, so we get 30 over 2, root 30 over 2. And we're looking for a positive time. So 30, root 30 divided by 2, that gives us 2.74 seconds. Or we could have done our 15 divided by 8 here and taken the square root of that answer. Alright, looks like I got a different answer. Alright, up here when I multiplied the top by 30, the bottom had to have been root 2 times root 2 doesn't cross out. It leaves you 2 times 2, which is 4. So I needed to divide this other part by that one more time, and we get 1.37. Root 30 divided by 4 is 1.37. That's better. Okay, factor completely. what multiplies to be x squared, what multiplies to be 8 and adds to be 6. Here's the difference of two squares. So these are conjugates of each other. The middle term crosses out. That's why there's only two terms. Difference of two squares. You can FOIL that to check your work. Take the square root of the first term. Take the square root of the second term. The signs are going to be opposites since there's only two terms. That is the difference of two squares. Here I see a common factor that can come out of each of these. Now these are prime numbers. So if they're prime numbers, maybe it's a good idea to try to guess and check, because 2x times 2x has to make 2x squared, and to get to 5 but a negative, be a positive 3 to get to positive 6 minus 1. If you FOIL that back together, we get 6 minus 1 and a negative 3. So that's my factoring. This is the difference of two squares. These are also the conjugates of each other, so when you multiply them, the middle terms cross out. Here I notice that there is a common factor in between all of these. And because it has a leading coefficient of 1, it's a little bit easier to factor. Looks like 5 and 1, that multiplies to be 5, that adds to be 6. So that's factored completely. I look here, I see the difference. So maybe this is a difference of two squares. But I can't take the square root of 18. I can't take the square root of 3. I definitely can't take the square root of p. But if I factor out 3p, that leaves me with 6p minus 1. That happens to be factored all the way. There's nothing else I can do with that one. Alright, here we could try guess and check, or we can just go into our factors. We're going to multiply a times a c to get to 30. That adds to 31. Well, that's clearly 1 and 30 multiplies to be 30 and adds to be 31. So you can complete, we can factor this by grouping. 1x and 30x make our 31x, and then our 6. Factor out what you can out of both of those. This is 5x plus 1. This is 6, 5x plus 1. So my answer is x plus 6 and 5x plus 1. There was no common GCF that could come out. Okay, this is an interesting one. I look at it and I see that this I can actually take the square root of. So I'm going to test something. Is this the difference of two squares? Or is this perfect square trinomial? This is 2y. The square root of 25 is 5. So is the middle term 2 times 2y times 5? Is the middle term 10 times 2? Yes, it is. So I know this answer is 2y minus, because it's always that term. Or you could have done it the traditional factoring way. 4 times 25 is 100. What multiplies to be 100? 10 and 10, and then factor by grouping. Okay, we can solve this one out. Add it to the other side. Divide by 2. Take the square root. Add 2 to both sides. 2 plus 9 and 2 minus 9. So we get 11 and negative 7 as our two answers. This has a b term in it. By the way, here I took the square root of both sides. You couldn't see that. Here, this has a b term in it. So I cannot take the square root of this the way that it is. I could try to do some completing the square. Maybe that wouldn't be so bad. I'll take my 2x squared plus 6x, move my 5 to the other side, factor my 2 out. No, because then that gives me an odd number. I don't want an odd number for that term. So that's not going to help me. I'm going to take that back. Alright, so if completing the square doesn't work, factoring might work. What multiplies to be 10 and adds to be 6? Nothing that I'm thinking of. So we are going to have to use quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Gives me negative 6 plus or minus 36. That is 10 times 4, which is 40. So this is x equals plus or minus. This is a negative 4 inside that square root. So this is negative 6 plus or minus 2I over 2, and I can reduce it to both sides. So negative 3 plus or minus I. This one's already set up pretty well for completing the square. So we're going to take x squared minus 22x and add 121 to both sides. So that makes x minus 11 my perfect square. So I completed the square. We have 121 and we're subtracting 31. That's what it looks like. 121 minus 31, so I got 90. So when I take the square root of both sides, I get x minus 11 equals plus or minus 9 times 10. So x equals 11. I add the 11 to the other side, plus or minus 3 root 10. Here we have it factored apart already, so we can use the zero product property. When we use the zero product property, we can set our two factors to 0. And I have my two solutions for where this graph will cross the x-axis. Alright, we don't have a b term here. If we don't have a b term here, there's no need to bring everything over to the same side of the equal sign. Alright, it's not very pretty looking. So we get plus or minus. Negative is going to use an I. We're going to have square root of 2 over square root of 7. We'll have to rationalize our denominator. So plus or minus I root 14 over 7. And here, because we have different types of x's, we need to bring them all over to the same side of the equal sign. Alright, and it looks like they have a common factor in there, which pulls out to be 4x squared minus 4x minus 3. 12. Alright, I think we can factor that. So we need two things that multiply to be 4. I think that's going to be 4x and x. could be 2 and 2. Maybe I'm thinking about it too long right now. Alright. So, this is what I was thinking of. 12 that makes negative 4. What multiplies to be 12 would be 2 and 6, but the 6 would have to be negative. So we're going to have 4x squared plus 2x minus 6x minus 3. So I'm factoring by grouping. So I don't forget about my 2. It's still sitting out here. So I'm going to factor out a 2x. Leaves me 2x plus 1. Bring down my negative. Factor out my 3. 2x plus a negative and a positive makes a negative 1. So I have 2x minus 3 and 2x plus 1. My 2 is in front still. Okay? In terms of solving, the 2 is irrelevant because 2 does not equal 0. I'm using the zero product property. So 2x minus 3 equals 0 and 2x plus 1 equals 0. That's 3 halves. Over here, that's negative 1 half.